Hello, Sudarshan here, and this is my vehicle warning system, which consists of a drunken driving detection as well as a drowsy driving sensor. Well, the first part of it would be the breathalyzer module. It has an MQ3 alcohol sensor, which has a heating element in it, and it consists of a 5 volt, a ground, and also an analog out for it, which goes to the microcontroller. The breathalyzer module is a homemade item that I made, and the holes here actually help because the alcohol sensor has a slow rate of cooling down, which is coming down to the actual alcohol value. These holes help the air circulation, which is something I made. This is the pipe in which you blow into. The next part is the ignition switch here, a simple on-off switch here, a reset button for the whole system, and this simulates the engine that is to be turned on or off. And these are simple LEDs that show you the state at which the drunken driving detection is at. So now I'll tell you what my system does. In fact, when you get into your car and you want to turn on your engine, that is, you want to flip the ignition, it will first ask you to blow into the module. Once you blow into the module, it will detect the amount of alcohol in your breath, and there's a slightly shady formula we use that converts the alcohol in your breath into blood alcohol content, which is what we use to regulate most drunken driving cases. And based on that threshold, it will either disable or enable the ignition using the relay that we have here, and it will display an LED alert as such. So if you are drunk, that is, it will not allow you to turn on the engine, which is disabling in drunken driving. But if everything's fine, you can turn on your engine and you're free to go. Now we'll take a look behind to see where all the magic happens. So the microcontroller I'm using is an MSP430 G2553 with a launch pad, and I'm programming it using CCS or Code Composer Studio. The .pcb here has the central part of the circuit, which consists of the wiring for the LCD, the 16:2 LCD here, and it also consists of the circuit for the relay and the switches here, which is the reset switch and the on-off trigger switch, and the wiring to the motor. Everything in this circuit is powered using the battery eliminator given here, set at about 5 volts for powering the circuit. Now let's have a look at this work. First, I'm going to blow into it without any alcohol content in my breath, that is, as a normal person would do. It's prompting me to blow right now. If you have a look at it, it tells you that no alcohol is detected, and the LED changes. Now this indicates that we are free to turn on the ignition. And the engine is started. Now for the second part, I'm using Listerine mouthwash, which is about 26% alcohol. Now I'm going to blow on the breathalyzer. As you see, the alert is sounded, and it indicates your blood alcohol content. And now if you try turning on the ignition, it's disabled. This would prevent drunken driving. There is one disadvantage, however, is that between two tests you have to wait a small amount of time, because this MQ3 sensor here has quite a large recovery time. That is, it cannot take two values simultaneously, so you'll have to wait a bit. So that's that. So this is the module. The next part in my vehicle warning system is a drowsy driving detection system, which uses image processing, which is OpenCV with Python, which I've used here. And what I've done here is I've used hat cascades along with a blink algorithm that I've written to actually predict the state of the driver as he is driving and give alerts based on whether he is drowsy or not.